Hello everyone, welcome to Math and Stat 3379. Today we're gonna talk about chapter 3. So chapter 3 is about numerical summaries of data. This chapter is gonna be a little bit long. We have a total of 50 slides. So we're pretty much gonna break down to 5 different videos to just go over all materials in chapter 3. So now let's start with the introduction part. So we have total 3 sections. 3.1, we're going to talk about measures of center. And then section 3.2, we're going to talk about measures of spread. And then section 3.3, we're going to talk about measures of position. So these are all numerical summaries of data. So let's kind of recall the definition for statistics. So we have 2 big areas. The first one, we call it descriptive statistics. Descriptive statistics. So chapter 2, we talked about the graphical part for descriptive statistics. And then chapter 3, we're going to talk about the numerical summary of data. So let's kind of recall, we do have a histogram, and then we calculate an average for the big data in chapter 1. So graphical, which is the material we discussed in chapter 2, and then for calculating the average, that's actually under the numerical summary. So now let's start from section 3.1, measures of center. So for measures of center, we're going to discuss the mean, the median, the mode, the weighted mean, and then how to compare mean, median, mode. So 5 different parts, and then let's start with the mean. So this is more like a review for most of you, because everybody knows how to calculate the average. So it is actually just found by adding the values of the data and then dividing by the total number of values. So now we're just gonna use some notation to represent the different values here. So we're gonna use x1, x2, xn. Remember the list of n numbers in the data set. So suppose we have n numbers. The first one, we're gonna use x1 to represent the first number, and then x2 represent the second one, and xn represent the nth number in the data set. Now, for example, the mean of data set 32654. So for this data set, we have n equals 5 because we only have 5 values there. So now the mean is found by adding those 5 numbers and then dividing by how many numbers in total for this data set. So we're going to say x1 is 3, x2 is 2, x3 is 6, x4 is 5, and x5 is 4. So we're going to add up x1, x2, x3, x4, x5, and then we got a sum of 20, and then use 20 divided by 5, then the average is 4. So 4 is actually the average. Now let's look at some more notation, summation notation. So this summation notation shows the sum of the total x values. We're going to use this symbol to represent the summation, which is the capital Greek letter sigma, and then it read as sigma. So sum of x means to find the sum of all the total x values in the data set. So the correct writing going to be sum of x equals x1 plus x2 plus x3 plus x4 plus x5, which is the representation of each x 3 plus 2 plus 6 plus 5 plus 4, and then it is 20. So for the mean of these data set, we're going to use this symbol, and we read as X bar. So we say X bar is for sample mean. So sample mean X bar equals x1 plus x2 plus up until xn divided by n, which is sum of x divided by n. So this is the equation for calculating the sample mean. This whole thing is the equation. And n is how many numbers you have in the data set. And then x bar is just the sample mean. And note that in statistics, we use Greek letters to denote parameters. And then the Roman letters are used to denote statistics. Now let's look at another version of the mean, which is called the population mean. And then we use this symbol to represent the population mean, and then we rate it as mu. So mu equals same thing. The only difference is since it's a population now, so we use the population size. So n, the capital N, represent the total number of values in the population. And then mu is a Greek letter, so it represents parameter. And then this is the population mean, which is a parameter. Now let's look at the example. So we're going to calculate the sample mean for the following data set. We have 20, 22, 23, 25, 40, 50, 80, 10, 5, and 3. So the solution going to be just write down the formula. So always write down the formula so that you don't make a mistake. So x bar equals everything add up together. So x1 plus x2 up to n, xn, and then divided by n. So that is sum of x divided by n. And then 20 plus 22 up to 3 and divided by 10. So the sum of all the values in the data set equals 280 divided by how many numbers? We have 10 numbers. So 280 divided by 10, which is 28. So this is the sample mean. And then the mean may not be a value that could not possibly appear in the data set. So 28 is not a specific number in the data set. It's just representing the average. Okay, so now since we finished the mean, and then we're going to talk about another measure at the center, which is called the median. So now let's look at part 2, the median of a data set. So the median is the midpoint of the data array. And then the symbol for the median is MD. We're going to use MD to represent the median. So since it's just the midpoint, so it's kind of straightforward. We're first going to arrange the data in an increasing order. So arrange the data in an increasing order. That's going to be the first step. And then the second step going to be determine the number of the values in the data set. And then step 3, we're going to look at whether we have a even count or odd count. And then if we have an even count, then we do not have a specific midpoint. Then we have to look at the center 2 value. 2 middle observations in the ordered list, and then we're gonna use that too to obtain the median, which is just the mean of the two numbers we have exactly in the middle. But if we have an odd count, then we have a specific midpoint, then the median is just that value. So now let's look at the example question. So find out the median for the following sample. 20, 22, 23, 25, 40, 50, 80, 10, 5, 3. So we're going to arrange the data in an increasing order from 3 to 80, smallest to the largest. And then now we're going to check whether we have an odd count or even count. So the count equals 10. So 10 is even. Now we know we don't have a specific number right in the middle. We have 2. Instead of 1, we have 2. So 22, 23. Then we're gonna say the median is the mean of these two numbers. 22 plus 23 divided by 2, which is 22.5. That's the median. And again, median might not be a specific value in the data set. So 22.5 is right in the middle and then represent the middle point of the data array. Now let's look at the practice. Find out the median for the following sample. So we can just rank the number from the smallest to the largest. Let's say 1.0, 1.5. And then we have 2.2, 2.3, and then 3.3, 5.8, 7.5. 1, 2, 3, 4, 5, 6, 7. So n equals 7. So 2, 4, 6, 7, no problem. N equals 7. And then now we know we have, this is step 1. Step 2. We know that we have out count. Then just locate the number right in the middle. Then median equals 1, 2, 3, 1, 2, 3, right in the middle, which is 2.3. So median is 2.3, the number exactly in the middle of the data array. So a median could be a number in the data array. So that's a practice problem. And then now let's look at another one. Find the mean and median for the following data set. For this data set, we're going to look at the mean and the median. So if we want to obtain the mean, then we're going to say x bar equals sum of x divided by n, which is 1, 2, 3, 4, 5, 6, 7, 8. 8 twos, so that's 16. And then 16 plus 20, that's 36. And divided by 2, 4, 6, 8, 7 numbers. So 36 divided by 7. So we're gonna use a calculator. Divided by 9. So we have 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. 36 divided by 9, which is 4. So the mean is 4. And then now let's look at the median. So n equals 9. The total count in the data set is a odd number. So we have a exact middle point in the data array, which is 2. So 1, 2, 3, 4, 1, 2, 3, 4. So this number is right in the middle. Then the median is 2. So these two values both describe the central tendency of the this data array. And now let's look at some information down here. So a statistic is resistant if its value is not affected much by extreme values. Extreme values means super large or super small small compared to the rest of the data set. So if we look at this data set, so 20 is kind of an extreme value. It could be a 2, but when someone record the data set, it's just by tap roll, they type a 20, it could be a 2. So this extreme value might be an error. And due to that extreme value, the mean is influenced. So the average should be 2 if we don't have this arrow, because if you have all 2s, and then the average should be 2. But because of this 20, the average goes from 2 to 4, which doubled. So this number influenced by the extreme value allowed. But the median, no. No matter whether you have this extreme value, the median is still 2. So then that is actually the reason why both mean and median describe the central tendency. But after we discuss mean, we still need to discuss median because the median is resistant, but mean is not. Okay, so after the median, let's talk about part 3 for this section, 3.1.3, the mode. What is the mode? The mode is the value that occurs most often in a data set, a mode. And then one data set can have many modes. For example, we have 2, 2, 3, 3, 4. So which number occurs most often in the data set? 2 and 3. So now we have 2 modes for this specific data set. And it is appropriate for all types of data, but most useful for categorical data or discrete data with only a few number of possible values. And when no data value occurs more than once, we don't say we have so many modes. We just say the data have no mode. Okay, now let's look at an example. So lesson nuclear reactors. The data show the number of lesson nuclear reactors in the United States for a recent 15-year period. And we want to find the mode. So we have a bunch of numbers, and the answer is 104 and 109 are the modes. So why? Let's check. So we have 104 5 times, and then we have 109 1 2 3 4 5 times as well. So both occurs the most frequent. Then we say the modes are 104, 109, and then the data set is said to be bimodal. Okay, now another practice problem. We want to find the mean median mode based on frequency distribution. So this is actually a single value grouping method. And then we have this frequency distribution. It actually tells us the real data set. We can actually write back the data set, but we don't really have to. If you feel you cannot just when you look at this frequency distribution, you cannot just think about the original data set. You can always write back like this. So we have 300 for 6 times. So that means we have 300, 300. So 6 times, and then 400, and then 450 2 times, and then we have 800, 940, and then 1050. So this is the original data set. Then if you want to find the mean, x bar equals sum of x divided by n. So sum of x, which is the sum of all the values. So we have 300 times 6 plus 400 times 2 plus 450 times 2 plus 800 plus 940 and plus 1050 divided by how many numbers we have? Actually, the total of the frequencies. So 6 plus 2 plus 2 plus 1 plus 1 plus 1. Then we have, now let me use the calculator. So 6 plus 2 plus 2 plus, so we have 13 numbers in total, and then that's 300 times 6 plus 800 plus 900 plus 1850 and plus 940. So 6290. That's the total, the sum. Then 6290 divided by 13. That's 483.8462. That's the mean. And then now let's look at the median. So since n is 13, which is out, then we have one number exactly in the middle. So we can just look at that number. So the value exactly in the middle. So 48. 13 divided by 2, that's 6. 1, 2, 3, 4, 5, 6, 7. So this 400 is going to be the value exactly in the middle, because we have 6 numbers ahead of this number and then 6 number after this number. So this is the median. So we're going to say median equals 400. And then mode. Mode is 300, no doubt, because 300 occurs 6 times. The most frequent occurred value in the data set. Then we got the median mode. So the measures of central tendency. Then actually, for this practice, what we did, we calculate a weighted mean based on the information. So now part 4, let's talk about this weighted mean. So the weighted mean of a variable x, by multiplying each value by its corresponding weight, how many times it occurs is actually the weight. So its corresponding weight, and dividing this the sum of the products by the sum of the weights. So now let's look at the equation. It's actually just what we did for the practice problem, but to write it down as the equation, so it's gonna be like this. So weighted mean equals the weight times the first number, and then the corresponding weight for the second one times the second value, and then so on and so forth. So sum of all the products divided by sum of all the weights. So the weights means how many times it occurs there. So now let's look at GPA calculation. The weighted mean is used. Of course, it's very useful, and then GPA is one of the typical example for weighted mean. So now let's look at this problem. A student received an A in English. So receive an A, so that means the student received 4 points in English. English is a 3 credit course. So that's the first information. And then a C in psychology. So C, that means the student gonna receive 2.0 for a 3. Let's write it this way. So that's for English, 3 credit. And that's for psychology. And then a B in biology. So B received 3 points and then 4 credits. Biology. And then an A in statistics. The A means 4 points. And then statistics 3 credit hours. And then what else? A D, which is 1 point for 2 credits. And then that's education. And then that's all, right? So English, 3 credits, psychology, 3 credits, biology, 4 credits, and then stats, 3 credits, education, 2 credits. Okay, so now based on this transcript, what is the GPA? So the points, the letter grade, or the points the student can receive is actually the values. So we use X represent that, and then these credits means the weight. Means the weight. And then now let's just use the formula. Weighted mean equals sum of Wx divided by sum of W. So now let's look at the denominator first. Sum of W, sum of weight. Weight means, sum of weight means in total how many credit hours the student take for this semester. So the student take 3 hours plus 3 hours, that's 6, plus 4, that's 10, 10 plus 3, that's 13, plus 2. So 15 credit hours for this semester. 15 credit hours, that's the sum of the weight. So equals what? 3 plus 3 plus 4 plus 3 plus 2. That's 15. And then sum of the product. So the student for the English class, the student received 4 points because a letter grade A, and then 3 credit hours, so that's a total of 12 points. And then a C, that means 2 points, but 3 credit hours, that means 6. So this is 4 times 3 plus 2 times 3 plus 3 times 4 plus 4 times 3 plus 1 times 2. And then we have 12 plus 6 plus 12 plus 12 plus 2. And then that's going to be, so this is all for the denominator. That's going to be what? So we got 18 plus 12, that's 30. 30 plus 14, that's 44. Divided by 15. And then we got, let's use another color to write on the final result. It's going to be 44 divided by 15, 2.93. That's the GPA for this student with this specific transcript. Okay, part 4, the weighted mean. And then now let's look at how to compare the mean, median, and mode. Still for this data set, we want to find the mean, median, and mode. The data set is for ages in a random class. So sample mean, we calculate it to be 23.8, and then the median is 21.5, and then the mode is 20. So you can actually practice problem yourself and then compare with this answer. And then now let's kind of recall the shape of a distribution. So if we look at a smooth curve for a distribution, and then we see something like this, and then we call this left skewed because you have a long left tail. And then for this kind of distribution, so from this line, if you flip it, you still got the same one. We call it symmetric. And then for this one, long right tail, right skewed. And then what's the distribution shape related with the mean, median, and mode? So this is what we have. So if we have the mean smaller than median, smaller than mode, because why it is like that? Because median is always located right in the middle of the data set. When you have a long left tail, because of some unusual small number, the small number gonna kind of drag the center towards to the small number, because you add some really small number, but still there's some weight for the small numbers. So you kind of drag that to the left. That makes the mean smaller than the median. So left skewed. When for left skewed data set, you have mean smaller than median, smaller than mode. And then symmetric, they're all equal. Mean equal median equals mode. And then for the right skewed, you have mode smaller than median, smaller than mean. Why smaller than mean? Because you have some unusual large number towards the right tail, and then those large number are gonna drag the average towards those number, because you add in some really large number, so you're gonna shift to the right side. So that makes the mean more than the median. So when we say mode smaller than mean, smaller than median, smaller than median, smaller than mean, then it's right skewed. Now let's look at the previous example. So what's the shape of this data set? We're gonna say the shape is we have mean more than median. So when mean is more than median, then we say it is right skewed. So we have a right skewed data set. Okay, so that's all for section 3.1. And then next video lecture, we're going to start from section 3.2, measures of the spread. Thank you.